All right, sup. Today we're doing we're doing a different type of coding strategy. Yeah, that's the word I was looking for. So we've finished up the modified binary search, and now we're doing top K. Um, yeah, so it's where you have to find like the K number of something, or like the kth position of something, or what, something like that. I don't know how else to explain it. I mean, maybe after this problem, you'll have a better idea. So I guess we'll just go into reading the question. Given an unsorted array of numbers, find the k largest numbers in it. No, for a detailed discussion. Okay, I guess this is something that we'll do tomorrow. Actually, I'll just take this line out. Actually, it's not really relevant. Yeah. Example one, you have the input, and then you have k equals 3, and you want to find, the k largest numbers in there. So without further ado, I guess we can just get on with coding the solution. So we're going to create a min heap. Actually, I guess before I start, from heap queue import everything. So we're going to be using things from the heap queue collection. So here we want for I in range of k, we want to heap push onto min heap nums I. So we want to push the first three numbers in example one. We want to push the first three numbers onto our heap. And since min heap, or like heap q, is implemented as a min heap, the smallest number will be on top. And then so for the first three numbers, the order for us will look like 1, 3, 5. And then so we want to find the k largest, right? So now we want for I in range from k to the length of nums, because that just handles all the rest of the numbers, right? Because for here, we handle for this question itself, we handle for the first three, we need to handle for the last three numbers, right? So from here, we'll handle from index 3 all the way to the number before this, which will just handle these last three here, right? So if nums I is greater than min heap sub 0, because this will be the smallest number we have in our heap, and this is the number that we're currently looking at. If it is, if the number we're currently looking at is greater than the smallest number, then we're going to heap pop off of min heap, and then we're going to heap push onto min heap the nums I that we're currently looking at, right? And so this will take us through the rest of our numbers, and then once we get to the end, we can just return our min heap here, and then we should have the right answer. So for this, well, this one's pretty easy because we have the solution out for us already, or it could be 12, like that, right? And here our solution will look like 12, 11, 12. So 12, 11, 12, whoops. Or it could be, 11, actually, the way our solution is going to make it work, it'll actually return 11, 12, 12. But, for these types of solutions, or like questions, they'll usually take any answer as long as your array contains the right numbers. Like, the order doesn't really matter because lists also aren't ordered. Unless, you sort them, then of course there's going to be a certain order. But yeah. So those are our two solutions. So if we were to run Python file in terminal, we get our top numbers 5, 12, and 11. Actually, I guess this doesn't, I guess we get 12 first. So if you've learned your data structures or whatever, at least in my data structures class, we were taught how to implement a heap like this. And so we were taught that, like, you make it in like a binary tree type of format. So even though I did expect our solution to look like this, if you were to implement a binary tree like the way Leetcode does it, and then the way that they represent it in a list, this would be the head, and this would be left, and this would be right, right? So even though this did show value 12 and then 11, they would be on the same level of the binary tree, and then when this gets popped off, it will look for the smallest value, like on the levels below it, and then propagate that all the way up. So this will still be the right answer regardless, and then this is what we expected here. I guess just as another example, I suppose, we can copy this here. We'll do this, and instead we'll do the top 5 numbers instead. So we should get everything but 1, right? So in no particular order, we should expect 5, 12, 11, 2, and 3, right? That's 6 numbers. We have 5 numbers here. Yeah. So in no particular order, it'll probably show up something like 2, 3, 5, and then look like this. It'll probably look something like that, but the 5 and 3 can be switched. 12 and 11 can still be switched. So let us run Python file in here again. So 2, 3, 5, 12, 11. Yep, that's exactly as we expected. And yeah, so yeah, that is the top K numbers. Thank you for watching.